Hi everyone. Today we will start here. This slide is talk about 2D element. The 2D element can be used to model the structural memory such as air crack, fish edge, skin, or car body, as shown here. And after final element modeling, the aircraft fluid edge scale can model can be modeled uh, like this way. And but this is very simple, very simple. As you know that uh, the aircraft is very complicated, but we need to simplify and modeling the uh, modeling the to get the structural analysis. So if you find the element type will be 2D plant element, such as plant and shower. The plant, what is the difference between the plant and the shower element? The plant element has a degree of freedom such as displacement or rotation. However, the shell element still has the same degree of freedom, but their difference is that the shell element has the degree of freedom in out of plane. It means that they can handle the problem. The 2D problem has the out of plane the deformation. So if so in this case, we need to use the 2D shell element to model the structure. Later, I will use the Chinese to repeat again to explain the detail. After that, I will exchange the exchange by the English version. 同学，这个问题呢是说有一个飞机的机翼哈，有一个飞机，它的机翼它的机身呢，我们要用 2D 的element 呢去做 modeling。那 2D 的 element 呢，基本上有两种，那其中有一种是叫平板哦，平板的 element。那另外一种呢叫做壳元素哈，板跟壳元素。那一般来说描述在那个做机身的那个有限单元法 model 的时候呢，我们通常会使用那个壳元素。那壳跟板的差异在哪里呢？壳跟板的元素差异在哪里呢？差异在那个壳的元素呢，它可以 model 在 out of plane 方向的一个物体。也就是说，这个如果今天那个板的元素的话，它只能描述在 SY 的一个自由那个平面。但是如果是壳元素的话，它可以描述在 out of plane 方向的一个问题哈。如果它的结构是有这个情况，但是它是 2D 哈，哦，也就是说弧面的话，这个问题它使用壳元素。但是如果它的那个二维的一个平面呢，它没有 out of plane 的一个变形的话，那基本上用板元素就足够了哈。好，呃。The next slide is talk about the 3D elements. 3D solid elements are used to model the thin, thick components such as the piston hand, shown as below. As shown in this figure is the piston model. The the model can be created from the SolidWorks and so on, and then import to find elements software such as ANSYS and Abacus. And after modeling the structure by free mesh, the final element model can be created like this way. and enlarge one of the elements, we can find the 3D element can show us show here. You can find that the node is at the corner of the element. For example, for this example, you can find that the corner totally has the four corners. So we have the four nodes for the element. And later, in the next slide, I will give you an example. Next time we give the student the example as the project, and the student need to take home to model the structure. Try the aid is to reduce the structural weight, but at the same time we need to maintain the structural stress. So this is need to your idea about how to reduce the structural weight, but at the same time the mechanical stress need to be maintained at the same time. Okay, the problem is that the design team has to create a nose landing gear, such as shown in this figure. The landing gear structure design for the new fighter jet determine if the landing gear structure has been designed properly to withstand the landing gear. So later I will give you the movie to see how to operate the landing gear during the flight and the landing, and how to do this the modeling job of the landing gear. 同学，这个是一个战斗机哈，应该是战斗机或是一个民航机，它的一个应该是鼻梁这边哈，就是鼻梁这边的一个的轮子哈的一个轮子在下降的时候，在那个在降落的时候的一个跟地面接触的时候，它会有一个结构的一个装置。这个结构的装置必须要做得非常的精良哈，因为它下降的时候，这个轮子呢会跟地面做一个接触的一个状态。那一接触的时候呢，基本上这个 landing gear 呢必须要吸收这个接触地面的一个冲击的力量，所以它的形状会类似像一个 C 字形的一个形状，但是在这个顶端地方必须要有一个类似像 spring 或是弹簧吸收的一个装置，不然的话实际上会伤到那个机身的。那现在我们再来看说要怎么 modeling。那上学期的时候呢，应该上学期或者之前呢，这个题目呢有当做你们的期末的专题，但是这学期是没有哈。那这个题目的发想呢，那时候是希望说同学能够做完这个 landing gear 的一个 modeling， 同时那目标呢是能够减轻这个 landing gear 的一个结构的一个重量，但是呢同时能够维持住这个结构的一个强度，所以必须借由 finite element 的一个 finite element 的一个 simulation 呢，来完成这件事情哈。Okay, let's move to the next slide. Next slide is talk about the landing gear structure. The show in this figure, as shown in this figure, the material the material of the landing gear is the steel. We need to know the Young's modulus and the Poisson ratio and the landing loading. The numbers of landing loading. The landing loading is applied at the top at the top of the structure, but we need to find some certain location to fix the structure. By this way, the rigid body behavior can be fixed. So first we need to so when we modeling the structure, first we need to create the landing gear, shown in this figure. 同学，这个是比量这个我们要说做 modeling 的这个 C 字的类似 C 字形的这种，应该是 C 字形或是 L 型的这个的一个结构的一个支撑的一个零件。那基本上这个零件呢，通常是用 SolidWorks 或其他的 KCAM 的AutoCAD 啊，或者其他软体呢，把它绘制出来，然后 import 到FEM 的软体里面。那这个材料呢这个结构材料呢，通常是使用金属材料。以这个 case 来看呢，是steel。那我们在做结构分析的时候，不外乎要知道它的一个杨氏系数，好，和普松比，如这个图所示，好，如这个表所示。那另外呢，我们也需要知道它的一个负载条件，在这边的话是7080磅。那这边并没有显示出它如何做这个边界条件的那个 setting， 好的一个固定的一个地方。其实我们上次有讲说，边界条件非常的重要。如果你边界条件一旦设定错误的话，那你的整个结构呢的分析呢，就是 garbage in garbage out。所以等一下呢，我们会说明说这个结构里面在哪个位置呢，必须要 fix 好，来得到一个比较接近实际的一个结果。Let's move to the next slide. Next slide is talk about the analysis, the procedure of the finite element modeling. The step 2 is to import or build a geometry. So when the when we create the modeling, the first we need to create import or build the geometry of the structure. How to do it? You can create it from the other software such as SolidWorks or AutoCAD, and then import the structure to the finite element software. As you know that the complicated structure is difficult to create by the finite element software itself, because the curve area and the other complicated the geometry is difficult to create by finite element software itself. The function is lower and poor, and as compared with other KCAM software. So I suggest you, if your geometry is very complicated, you can create the structure by other software and then import the structure to the finite element so well. However, if your structure is very simple, such as the qubit or rectangular or or other very simple the geometry, at this moment you can create the the structure directly in the finite element software. Such structures, such the application, for example, the electronic packaging and the semiconductor device. Such the structure are very simple as compared with the traditional machine and the other very complicated the industry machine. So this part is very important. It's very important. It is noted that you need to create the solid the structure, solid 3D structure. Not it means the structure need to have the valence item. Cannot do its way, only have the area but do not have the valence. If you do it like this way, you need to spend a lot of time to create the valence from the finite element software. So I suggest you, if you create the geometry, you need to create the 3D structure have the valence component. 同学，这个就是我刚才有讲的哈。如果你要建构这个有限单元法的结构，你有两种方法。第一个呢是直接在有限单元法的软体里面呢建构这个复杂的结构建构这个结构。但是如果你要在有限单元法的软体里面直接建构这个结构的话，前提是这个结构必须要简单稍微简单，因为有限单元法的软体里面的这个建模的能力，并没有其他的一个专门做 KCAD CAD 软体这么好。那像比较复杂，比如说有弧面啊，或是比较很奇怪的一些不是很奇怪啦，就是说那个比较复杂的一个结构的话，那如果你要在有限单元法软体里面直接做出来的话，是你要花很大的功夫而且不见得能够做到。所以如果比较简单的结构，譬如说是电子封装啊，或是半导体的元件这种比较方方正正啊，方方正正的这种结构的话，这个 geometry 的话，你可以用这个finite element 的这个 software 的功能呢，就直接在里面建构出来了。但是如果是结构是非常复杂的话，我建议你们还是使用 SolidWorks 或其他的一个 AutoCAD、POE 这些软体，把这些复杂结构画完以后呢，再 import 汇入到这个软体里面，然后再做后续的一个有限单元法的 mesh 网格画的动作，有两种途径。Okay, let us move to the next slide. Next slide is let. Next slide is next step is to create the analysis model. In this example, we use the finite element. We use the page chain or notch and the notch chain finite element software. The page chain, the function menu of the page chain is shown in this figure. You can let this is very easy to operate. operate and perform such the function step by step from the left to the right. So by this this item, this the button on item, you can create the following function. From the left, the first you can create the finite element mesh, and then apply the boundary condition and apply loading at the same button, and then create the material properties from the materials button, and then assign the element properties. So when you finish this function, basically you have finished the finite element model of this structure. In other words, you have finished the pre-process of the finite element method in ANSYS and other finite element software. So how to do this the job? We can see next slide. 同学，这一章呢是讲说如何建构这个分析的一个模型。那这个呢使用的一个 example 的一个有限单元法的软体呢是 MSC 的一个 Patron 跟 Nastran。那 Patron 跟 Nastran 等一下我们会讲啊。Patron 实际上 Patron 跟 Nastran 它是两个不同的一个软体但实际上这两个软体在 ANSYS 这两个软体的功能在 ANSYS 在其他的 ANSYS 的软体或是 Abacus 软体呢是被整合进来的。怎么说呢？ Patron 的这个软体呢，它主要只是做前处理跟后处理。前处理跟后处理就是 ANSYS 的前处理跟后处理。等一下，我们现在讲一下什么叫 ANSYS 的前处理跟后处理。应该说也不是 ANSYS 的前处理后处理。基本上 ANSYS 的前处理呢，就是指我要 create model 建这个几何，然后建构这个有限单元法的那个模型mesh， 然后assign 这个 boundary condition， 然后指定这个材料系数等等。那指定完这些动作之后呢，在前处理做完这个动作呢，基本上你的整个有限单元法的模型就已经被建构完成了。那建构完以后呢，之后就是要做 solve 的功能，solve 的一个功能，也就是要求解。那求解完以后呢，那求解的功能在 Patron 这个软体里面呢，是没有的，必须要再把这个 model 呢丢到这个 Nastran 里面，再去做求解的动作。求解完以后呢的结果呢的档案呢，又要丢回这个 Patron 里面去看后处理的结果。但是这些在这两个软体丢来丢去的这个动作呢，其实现在在刚才讲的在 ANSYS 里面或是那个 Abacus 里面呢，都已经被整合在一个软体里面就能够依序做完这件事情。所以现在看到的 Patron 的这些功能，实际上 ANSYS 里面就是所谓的 pre-process， 就是前处理的功能。那基本上分析就 finite element 的建模呢有三个部分 ：pre-process、solve and post-process 后处理。前处理、求解、后处理。那各位只要记得说，前处理就是做这件事情，就是建构模型、建构网格、指定边界条件、指定 material property， 指定每个 component 就是模型里面每个 component property， 这样就完成了。那至于在求解以后，求解呢的步骤呢，你可以指定所谓的apply boundary condition， 还有 apply boundary condition 就是束缚那个边界条件，还有给 loading。那这两个部分其实在前处理可以做，在solve 的话也会再提醒一次。那接下来就做求解。 求解的话就是交由软体运算，运算完以后呢，再由后处里面去看，譬如说你要看应变啊、变形啊，或是温度分布等等 ，depends on 你的分析的一个属性，比如说你是做结构分析，或是做温度分析等等，都可以这样做完。Okay, so the patron, the major function of the patron is to create the finite element modeling. So in this step, you can assign the element type and the mesh. After that, you can apply the boundary condition and the loading, and assign the material properties for the component within the structure, and so on. After that, but all the function is need to finish within the pattern patron, and then you can send this the file to the next chain to solve, to perform the solve function. After solve, you can get the solve result and back to patron to see the final result, and to see the final result, such as plot the deformation distribution and the temperature distribution, depend on which the analysis you perform. For example, structural analysis or heat transfer analysis, and so on. So this slide just describe the how to create the finite element model, and the detail you can follow see the following the slide. In this slide, just how to create the finite element model. Create the finite element mesh by this button, element button, and then apply the boundary condition BC as apply the boundary conditions, and in this case, we constrain the hub cylinders at the bottom of the structure. Yeah. And then we apply the loading to the upper face of the structure. And then we apply the material properties such as the Young's modules and the Poisson ratio by this button. After the put this button, you can find the table and input the Young's module and the Poisson ratio, then the value here. And then you can create the element properties for the landing scale structure. And in this case, you can put this name steel, okay, like this way. After that, you need to submit the model to the next chain, just I talked about in the previous slide, to perform the linear static analysis. For in this example, we just perform the linear static analysis. However, you can you may be asked, can we perform other analysis more, such as nonlinear analysis and heat transfer analysis and transient analysis, and so on? That is depend on what kind of element you assign and what kind of the material model you input. In this case, the analysis type is very simple because just one material properties, one kind of a material property still, and the material property is Young's modules in the linear Young's modules and the Poisson ratio. We do not input the yielding point and temperature dependency multilinear stress strain curve for this structure, and we do not input the specific heat and conductivity property and so on. So we can, in this case, we cannot perform other more complicated the analysis because depends on which material property you input. 同学在这个分析里面哈，我们所指定的那个分析的一个模式呢，是线弹性的哈，线弹性的一个静态分析。那线弹性的静态分析呢，基本上是在结构分析里面是最基本而且简单的哈。那这个 case 里面又是简单里面的更简单，主要的原因它只有这个结构的材料呢，第一个它是线弹性的，线弹性分析只要输入两个东西，输入两个材料性质。第一种呢是所谓的杨氏系数，第二个呢就是它的普松比。那这是线弹性的分析，之所以说非常简单，是因为它并没有考虑到所谓的 yielding point， 就是降伏点。那各位如果学材料力学就知道了哈，只要有过降伏点哈，只要设定降伏点呢，就是让这个分析呢有可能会产生所谓的非线性的一个分析，分析的分析。那当然，你设降伏点或是设跟温度相关的一个温度相关的多段线弹性的一个应力应变曲线的话，那你做的材料性做的这个结构力学的一个行为就可以变得更加的复杂，而且更接近实际的一个状况。那当然，你也可以做所谓的热传分析或其他的一个跟时间相关的分析，但是这时候呢，你必须要把相关的个材料系数都能够指定上去。比如说，你做热传分析的时候，你可能要设定它的所谓的热传导系数啊。热对流系数啊，还有相关的一个热边界的一个设定而已。还有你的 element type 是不是能够支援你做这些结构或是热传分析？所以这个结构分析的一个 type 呢 ，solution type 呢，必须 depend on 你的材料系数，还有你的那个复杂度，还有你的 element 的选择的不同。你是否结构分析呢，还是热传分析 ？OK， in this step, in this condition, we perform the linear statics the simulation, and then we put this result. We put this result to the Nast train, and after solving, and we got the result file like this way. We got the result file from the Nast train, and the result file read by the patron again to perform the post process. And so in this slide, you can see that we read the analysis, the result into the patron, and then we can get the the temperature, we can get the displacement, the distribution or deformation distribution, and the product in the windows or in the windows. And from this window, well, from this figure, you can find that uh, the maxima stress or deformation is at this location. So how to analyze analyze the the deformation contour depends on the color bar. The color bar. The color bar. For example, if the color close to the red, it means the deformation is positive and become larger and larger. If the color bar is the color in the color bar is close to the blue, blue, it means the values is small and small. Sometimes it will be negative. It means the deformation becomes smaller and smaller. Sometimes will be induce the compressive the stress. The positive the deformation. The location of the positive deformation is mean where the location will be induce a tensile stress. OK， 同学，这个结果呢是刚才讲的，就是说我们做完这个前面的这些档案以后呢，经由这个Nastran 求解完以后呢，必须把这个求解完的档案呢再丢回这个 Patron 里面呢来做这个后处理的一个观看哈。所谓后处理就是看这些这个结果，这些结果。那这些结果呢，不外乎就是你要看它的变形变形的话，基本上就是 plot 这个 displacement 的情况。那变形知道以后呢，你也可以求它的一个 the stress 的一个 distribution， 就是应力的分布。那基本上怎么观看这个 plot 这个 displacement 或是应力的分布，热传也是一样那颜色就是要看这个 color bar， 这个 color bar 的数值通常在处理后，处理这个做有限单元法的那个结果分析是很重要的通常颜色越红的地方，代表是越严重的地方。所谓越严重，就是代表说它的变形或是应力是远高于其他地方。通常这个地方就是我们关注的嘛，因为这个地方会有一些可能会破坏呀，或者应力集中的情形。当然，负的地方也会关注通常颜色越蓝的地方，或是越浅的地方就是代表变形量不厉害，对不对？不厉害，没有那么严重。但是有时候浅的地方不代表我们也要看，为什么呢？有些是正的最大值，有些是负的最大值。正的最大值跟负的最大值相对，就是说这个地方会产生拉应力，红的地方会产生拉应力。那以确实来看，红的地方产生拉应力，负的地方会产生所谓的比较小的拉应力，或是甚至有些地方会到达负的最大值。所以这个必须要再根据你的 case 呢去做判断比如说你到底是关注是在那个拉伸然后最大的地方，还是压缩最大的地方那就要 case by case 来做这件事情。Okay, let us move to the next slide. And the final step is publish analysis result. this part is very important because sometimes you need to catch the such image and put it in your homework and the project the report. So in this slide it is teach us how to capture the image from the patron. So you can find the menu. We have a file, and you can find the image here. And then click this image, and you can get this the window here. On the file and the image or result create quickly plot. You can create the status and such image for report and presentation. As shown in this figure, shown in this figure, actually we prefer this image, not this image, because the background is white, not black. OK， 同学，这一页呢是教大家怎么去做这个截取你想要的一个分析的一个结果档案哈。通常我们会用这个 image 哈，要截取这个影像的方式呢，去截取你要的一个结果档。那这个结果档呢，通常截取出来呢有两种方式哈，一个是你的 background 是白色的，一个是结果 background 是黑色的。那实际上这两个呢都可以，但是一般来说我们是比较 prefer 这个白色为底的一个结果，看起来会比较清爽一点哈。那黑黑的话，基本上就觉得说会使用墨水很多，而且如果你贴的图片很多的话，整个报告都是黑色的话，看起来就是不是很清爽哈，好像是你的报告已被印坏掉的感觉。所以我们通常都会使用白色为底的一个的结果，好，来当做这个报告的一个图片所需要的图片。在这个步骤以后呢，基本上已经完成了这个分析哈。那这是一个很简单的一个有限单元的模型的在软体上的操作。实际上的操作在我们的课程里面是使用 ANSYS， 在稍后的时候呢，我们还是会有一个这学期还是会有一个实际的安排一个实际的一个上那个演练哈跟说明哈，这样你们的 project 才能继续做下去，还有考试哈。So at this slide we have finished the simple analysis from the final analysis software patron and NAS chain. Actually, all the procedure are very similar to the procedure we need to learn from the ANSYS. The ANSYS we will explain the detail and in class, in the computer classroom. By this way, you can learn how to operate the ANSYS software, the basic operation, and the assistant will teach you how to operate the ANSYS. After that, you can finish the project and the homework and exam in this course. Okay, so let us move to the next slide. So this slide is summary the patron and the NAS chain the workflow. The first in the patron, we need to perform the pre-process, such as the import and create the geometry and create the final element mesh, and then apply the boundary condition and apply the loading. Then create the material property and create the element properties. After that, submit the model file to solver. The solver is belong to the NAS-train, so then we need to send this file to the NAS-train, the software. And the solver will solve for displacement. The displacement is raw data of the final element model. The displacement is belong to the node. So after solving the final element model, you can get the nodal displacement in the modeling. In this the fund model, and then compute the strain and compute the stress, and then we can get the analysis, the result, and back to the patron to perform the post process and the plot, and we can get the deformation plot and the stress fringe plot, and finish the report such as homework and the project report and so on. Okay, so the overall the workflow for the patch and the NAS-train are finished and shown in this slide. So later I will give you some movies for different case. For different case, and this is the air gap. Okay, and the car and this slide. Sorry, this slide is the airbag, and later I will put the movie in beyond the slide. Beyond the slide, you can watch the movies. This the slide just image the force impact from the other car when from the side of the car driver. So the analysis is simplified like this way. So, and the detail you can see the movie. 同学，这个是讲这个模拟这个驾驶后在驾驶的时候受到这个侧撞的撞击哈，就是像就是老师之前有提过哈，像我们在开车的时候，实际上开车是基本上能够有结构支撑的地方，就是有一些那个结构柱体的地方哈。像如果说你的车门啊，基本上只是一个保护的动作哈，并没有很强的一个结构支撑。好，比如说钣金的地方，其实各位同学也可以知道，那个钣金的地方哈，真的非常非常薄，你用手敲下去以后哈，就一个凹痕在那边。那一般来说，钣金的话只有几个，好像只有1到2个 mm 的一个厚度而已哦。当然，比较贵的车子哈，它钣金会比较厚一点哦，就名贵的车子还是有差哈。但是实际上，不管是钣金的，但是只是有钣金，但是如果没有结构的 的一个柱体的保护的话，支撑架的保护的话，那个地方通常都是很脆弱的。比如说车门的地方，其实车门的位置就是很危险的地方哦，很容易受到一个侧撞的一个撞击，就那个侧撞的撞击哦，就那个让我们受到生命危险哦，生命危险，因为这个地方哈，如果你那个驾驶呢，你的侧面哈受到一个外在的车子啊或者什么东西撞到这个地方的话，其实保护力是很弱的哈，所以基本上哈，车子哦，你可以想象，其实整个钣金哈，只是一个装饰保护的一个的动作啊，只是让你免于晒太阳啊，免于被风吹到啊。但是实际上真的受到外力作用的话，还是车身的结构体哈，结构体的部分很重要哈。所以基本上我们在做模拟分析的时候呢，在做车体的模拟分析的时候，通常都会着重在结构体的一个加强，很少看到那个比较少看到哈，就是整个车身哈，刚那个钣金哈都会继续模拟，因为钣金能够承受的冲击力量比较小哦，比较小。OK，this slide just show you another analysis analysis for the car impact to the wall and to the wall. But at this moment, at this moment or situation, sometimes we usually do not use the ANSYS the software, but we use another kind of another kind software such as LS Dyna to finish this the job. 同学通常做这种动态分析哈的一个有线单元法软体的话，通常我们选择是使用 LS Dyna 哈。LS Dyna 专门是做那个动态力学分析的一个软体哈，所以基本上在汽车厂比较的研发大厂哈，基本上 LS Dyna 这种动态模拟软体哈，使用的是非常普遍的。那 ANSYS 的强项哈，并不是在这一块哈，所以基本上每个软体还是有它这个比较强的一面。那这个分析呢，通常是这个分析是做汽车偏位正面的撞击哈，就偏向驾驶座的一方哈。那实际上你如果后面有电影那个影片的话，你可以看到实际上它撞完这个墙以后呢，实际上这个车子呢会做一个旋转的，有一个旋转的一个位移哈。This is another kind of the analysis. The impact is from the side of the car, and the impact directly meet the driver. The driver is very dangerous at this case because we need to ensure the safety of the car. So different kind of loading will be applied to the car from the front. The loading may be from the face or back and the side, and so many other loading condition will be considered in the car. Sorry， 同学，这个汽车撞击通常会来自于有我刚才偏位的撞击哈，正面撞击或者侧面撞击等等哈，那也会来自于背面哈，那各式各样的都有哈。Okay, in this slide we just image to simulate the impact analysis simulation analysis for the car. Sorry, for the train. The left side is the simulation result, and the The right side is actual validation the test result. This slide just show you that how to demonstrate or validate the simulation result is correct or not. We need to validate by the testing, actual test. If both results are very close, it means the simulation, the procedure, and the final element model are reliable. 同学，这个是说哈，我们通常怎么去验证你的模拟结果是正确的呢？通常我们会，这模拟结果正确呢，不外乎就是你刚才设定，我们刚才讲的，你如何简化这个 model， 你的材料的选择，你材料的选择，还有你的编列条件，你的 loading 给法是不是正确的？那通常我们都会做实际的实验，实际的实验。那当然，这一页呢是讲火车车厢的一个撞击的一个比较的图。那我们从比较图呢，我们通常还是要做一个实际的一个测试的结果，去比较我们的 simulation 结果是不是正确的哈。那如果两者的结果，不管你的撞击的deformation 的变形啊，或是加速度啊，或是那个损坏情况，如果是非常接近的话，就代表你的模拟是非常成功的哈。This slide just show you another analysis for the chain for the hand of the chain, and later I will upload the movie for this the analysis. This is another the analysis for the chain box for the chain box of the for this case. And this slide just show you the metal block impact by the rigid body plane or wall. Okay, you from this movie you can see that the deformation condition of the metal block. At this the simulation, you can see that the deformation, the plastic deformation is induced. For the metal block. It means when you simulate the deformation condition, you need to input the yielding point in the metal material properties. 同学，通常这个分析哈，如果你要知道说这个金属变形的状况啊，变形后的情况，就没办法像前面就没办法像前面的分析一样，只设定那个线弹性的那个仰视系数 point ratio， 你必须还要设定所谓的 yielding point， 就是我刚才讲的，你要设定 yielding point 以后呢，这个材料性质呢，这个力学的一个 model 才有塑性行为的产生。所谓塑性行为的产生有永久变形，对不对？永久变形就是说我做到转子以后，我的变形就回不去了。变形就不会回弹到原来的形状，这叫做永久变形。所以一般来说，我的降伏点的设定的大小跟精确度就要拿捏得非常的准。那通常都用实验的方式来得到这个降伏点。And this slide just show you a ball impact a plane impact a plane. The material of the plane may be glass. So when the ball drops and impact the glass plane, the glass will be break. So the simulation simulation is emulated this condition. And later still have a movie can be watched. 同学，这个投影片这个分析呢，主要是讲有一个圆球呢冲击到一个平面，这个平面的材质呢是用玻璃制作的，所以当这个圆球呢撞击到这个平板以后呢，基本上这个玻璃平板呢是会碎裂的情形。那这个分析呢，实际上在 ANSYS 里面是没办法做到的哦，但是 LS-DYNA 是可以完成这件事情的哦。但是你还是要选择适当的 element type 哈 ，element type， 因为有些 element type 才能模拟这种情况。好。Okay, this slide just talk about the heat transfer analysis of cylinder head. As you can see that the geometry is very complicated. Okay, so if you want to create such the model in finite element software directly, wow, this is a huge work, right? So I suggest you to create such model in POE and AutoCAD and SolidWorks, such the KCAN software, and import the structure into the finite element, the software. Okay, so this is the model. This is the model cylinder head, the model created from the POE. And the top view of the structure are shown here. And the bottom side of the slide is show you the part of the cylinder. Sorry, it's a sorry. The bottom side is the the finite element model is the finite element model of the cylinder body. Okay, cylinder body. And the cylinder head and the body are assembled by the brought. Okay, so you can see the location of the brought 1, 2, 3, 4, 5, 6. Totally have 10 brought. We need to use to assembly. Need to use to finish the assembly the procedure, and and actually, as you know that when we as you know that we need to the gasket between the gasket 垫片 between the cylinder head and the cylinder body to enhance the CLV function of the CLV function of the engine. So you can see the detailed modeling for the cylinder body and the brought。同学，这个是这个 model 呢是引擎的热传分析和结构分析的 model。那基本上引擎的操作的是非常复杂哈，引擎操作是非常复杂的。那基本上我们在做这个模型的时候，难度有2个地方。第一个是建构这个很复杂的一个钢头的部分，这是钢头哈 ，cylinder head 钢头的部分。那个钢头的部分呢，我们这个在这分析里面是要知道这个钢头的隔热传分析，好，热传的分布也是温度分布。另外就是希望知道说它的螺栓，这个螺栓哈，把这个钢头锁进这个钢体的部分，它的密封性好不好？密封的程度好不好？好，它的密封程度好不好的话，各位可以知道，其实我们在锁东西的时候，2个东西在结合的时候，通常中间会有一个垫片，好 gasking， 好 gasking。那这个 gasking 呢的设计就很重要的，就影响到它密封性能好不好。如果密封性能不好的话，基本上这个它的引擎的那个效能啊就会变差，主要是因为有些气体呢就会外泄哈，燃烧那个点火爆炸的在这燃烧室爆炸的那个气体就会外泄，那基本上化学能变成机械能的一个效率就变差哦，就确率表值变差。OK， let us move the next slide. How to finish the final end model of the cylinder head. So you can image the the structure of the actual engine. We can find that this is a cylinder body. You can see that we have the water jacking close to the fail run, close to the fail run and the fail run and the fail run, and we need to use the bolt to assemble the cylinder head to this body. The cylinder head is very complicated. We need to create the hole of the spark plug and the valve at the back of the cylinder head, include the inject and the exhaust the valve, and the contact area between the cylinder and the hand gasket need to take into account. So from the backside, the final element model are shown here. This location is the hole of the spark plug, and these two locations are the assembly location of the bolt. Okay, so the first step we need to finish the temperature displacement. Temperature distribution, and then we input the temperature distribution to structural analysis and combine the structural boundary condition and the loading condition, so we can simulate all the condition during the engine operation. 同学，这个呢，基本上是在做热传分析哈。首先我们会做热传分析。那在做热传分析，为什么要做热传分析呢？基本上各位可以知道说，热传分析会有温度分布。那温度分布的话，会影响到它的热应力。那热应力呢，会影响到后面的所谓的螺栓，好，这个螺栓哈，组装这个钢头到这个钢体的一个气密的一个性能。所以基本上结合不同的什么热点火啊、 人启动啊，这些的的操作条件，我们就可以把引擎在运转的各种情况，都考虑进来。好，那去测试它的一个钢头跟钢体之间的一个密封的一个程度。那从这个照片可以知道，其实，在气缸在这气缸的周围呢，实际上是有所谓的水道，英文叫做 water jacking，那就知道那个冷却水道，这个冷却水道是装满这个冷却水，冷却水。那注意一下，这个冷却水是有掺杂一些特殊的一些成分，原因是因为其实钢体在运转的时候，温度一定都大于100度，通常会大于100度。你这个冷却水的话，我们希望说它超过100度的时候，它还没到达它的熔点，所以冷却水的这个冷却水是特殊的一个冷却水，它的熔点会超过100度，以上，至少在运转的时候，它不会跟着沸腾，因为如果这个冷却沸腾的话，会有一些水汽压，你在引擎的时候，在运转的时候，啵的，这个声音就会造成一些震动，这个震动，那实际上是不对的，所以基本上这个水道的冷却水的温度呢，的那个它的熔点温度就调得比较高一点。那实际上这右边呢是它的钢头，并不是它左边这张图的有限单元法的模型不是，并不是。那从这里面你也看到红色的区域呢，实际上是我记得是好像就是我记得是好像是水道流过的地方水道的是水道流过的地方。那蓝色的地方呢，就是进气阀跟排气阀的的那个通道的通道。好，这个是这个是排气阀，这是进气阀。好，那各位可以看一下，这是从这个眼睛从底部往上看，底部往上看，所以这个地方是燃烧室的位置，燃烧室的位置，这个是火星塞，spark plug 火星塞，螺栓在这边，我们是建1/2一缸，截取一缸，捡取一个缸，然后建1/2的对称 model，对称 model。那各位可以知道说为什么什么原因我的进气阀会比较大，排气阀会比较小？为什么是这样做的？各位有没有什么的想法呢？好，我们这边先公布答案其实基本上呢，这个点火爆炸以后呢，这个气缸里面的温度跟气体都是压力很大，温度很高，所以我排气阀只要稍微打开一下，整个气体就会很快速的窜到外面，因为要泄压嘛，所以基本上进气阀不用做太大，它就可以达到泄压的功能，泄气的功能。但是进气阀呢，因为我要吸空气，那空气基本上是冷的你要用很大的一个那个的开口呢，使这个空气能够通进来，然后通进来以后再跟适当的一个撒油，对不对？撒油做一个油气的一个混合，然后再点火。所以也就是说，为什么我的进气阀做的会比排气阀还大的原因是在这里老师也是做了这个研究才知道这件事情好，那actually this is a final element model for the cylinder head, and we focus on the temperature distribution close to the cylinder head, the cylinder head. And the next slide we will next step we need to consider the structural analysis of the cylinder head, as shown in the figure. When we do the analysis, we have several assumptions. The first, the four-cylinder head possess the structural analysis, and then for the application of the pre-stressing of the broth, the construction of the partial block is needed to pour into the the effect of the gas-skin sealing. The third, according to the actual dimension, the full thickness of the gas-skin here is 0.4 mm. In addition to the red portion of the stepper at the location of the inner ring. Okay, so the third is the detail for the geometry description. The for the geometry of the gas skin, and as you know that when we perform the structural analysis, we need to have three parts. One is the cylinder body, cylinder hand, and the gas skin is insert between these two components. And in addition, we need to have the bolt to finish the assembly of the engine. So the figure of also this figure just the final model of the engine for one cylinder head for the engine. Okay, so let us move to the next slide. This figure just shows you the distribution of the temperature. You can see that the maximum temperature is close to the spark plug. Okay, this is easy to understand, right? Because this is easy to understand, and because we have the water jacket at this location and this location, so the left side and the right side, the temperature is smaller than the top and the bottom side, because these two locations have the water jacking here, so the heat will be taken away to the other location. But the top side and the bottom side is close to another the location, and these two locations do not have the water jacking, so the temperature at this location is next maximum temperature. 同学，这个呢是温度引擎缸头的其中一个气缸的一个温度分布的结果哈。各位可以知道，其实在中间的地方其实是温度最高的，主要是这边有火星山点火爆炸的位置，所以这个位置是温度最高。那其实上另外两侧的地方，它的温度会比较低，主要原因是因为刚才讲说有那个冷却水水道流过这里，所以水道的水能够把部分的热呢带走。那上面跟下面呢，基本上我们是做结构对称。其实这是其中一个气缸，上面跟下面有其他气缸，气缸跟气缸之间并没有水道流过，所以你可以知道，除了这个火星山是最大的一个温度的集中点之外，那下一个比较温度大的地方就是在气缸跟气缸临近的一个位置这边。And the right side of this slide is the distribution of the stress and the strain. You can see that the maximum stress and the strain is very close to the location of the bolt assembly. This it is very easy to understand. But we in this but in the structural analysis we need to care about the sealing function. So we need to consider the pressure, the pressure, the contact pressure and the gasket. So as shown in this figure, for this kind of engine, the safe pressure is about 8 megapascal. But in our simulation, we can get the minimal contact pressure is higher than this value, right? So it means the design for the gasket is acceptable for the sealing function. So the analytical results show that the distribution of the temperature in the internal structure of the cylinder head has an influence on the distribution of the contact pressure of the gasket, right? Because the some increase in the temperature distribution will include more thermal stress at the same location。同学，这个结构分析呢，我们可以知道说，其实最大的一个应力分布或应变分布，实际上是在螺栓所住的位置那这个地方是没有问题的这个是还蛮容易直接理解的。但是我们所关注的位置呢，是在那个垫片的密封的所提供的一个密封的的能力。那以这个设计来说的话，它能够最低能够使这个气体不外泄的的压力值呢，基本上是8.04 MPa， 但是我们计算出来的结果呢是24点多，远大于这个值，所以基本上在这个分析里面，我们可以知道说这个gasket 的所提供的密封的能力是足够的这个设计是足够的。另外值得提供的就是说，其实我们刚才讲说为什么要做热传的分析呢？主要因为热传的一个温度分布，它会转换成所谓的热应力，在结构分析里面，所以温度越高的话，代表这个位置的热应力会越大。那热应力越大的话，会直接影响到垫片上面的一个密封程度。所以我们刚才讲说，在冷启动、热点火各个运转情况下面，它作用在这个垫片上面的那个接触压力呢，都会不同那基本上都会不同所以我们必须要考虑到这个引擎在各种不同运转情况下面的一个垫片的一个密封性能。那这个分析里面就结合了所谓的热传跟结构的分析先做完热传，再做结构的一个顺序分析。那以当时来说，这个分析已经做了超过20年接近20年，所以当时分析来说，这个分析算是非常的难非常难，而且它使用的 element 数目也没有很多，大概只有快接近4万个 element。OK， let us move to the next slide. Next slide just show you how to build a finite element model. The finite element model approximates the behavior of a continuous structure with a finite numbers of elements. Yes, just we talk about. Okay, we understand this the sentence, and then as one increase the numbers of elements and that is decrease the size of the element, the result become increasingly accurate, but the computed time also increase. This also understand because we mesh smaller and smaller element. It means the numbers of elements increase greatly. So the computer time will be increased greatly, right? The finite element model provides several modeling tools to help the researcher build finite element model with the right balance between the accuracy and the model size. Just we talk about that. You can modeling the structure by smaller and smaller element, but not infinite. Okay, because we need to consider the computing time and the accuracy. As you know that we will perform the numerical converge analysis. It means when the element size increase to a certain number, the accuracy may be will be obtained with an error maybe smaller than 5% or 3%. But if the numerical result at this condition you can accept, so it means the model with the finite model with the such kind of the element number should be good enough. 同学，这个基本上我们建构 finite element 有几个点要讨论哈，就是说基本上有限单元法呢，基本上能够去近似一个连续体的一个力学行为，用一些一定数量的一个element 数目就可以达到，这是合理的哈。那另外就是说我 element 数目如果增加的话，也就代表说我的 element size 越切越小，在这个结构里面，那代表说我 element 数目增加嘛，那基本上我的数值的精确度就会提高，这也是合理的。但是要做到无限多吗？并不需要哈。我们前面有讲说，其实我们做那个数值收敛器分析的时候，我们可以知道说，当我的有限单元法的元素数目到达某一个数量以后，基本上我的精确度就已经足够了哈。Okay, how does finite element work? How does finite element work? So from this slide, I will introduce the basic approach. Give you as an example. The first, a given problem is described discretizing by dividing the original domain into simply shaped elements. For example, this is the concerned structure. Okay, the structure is modeling by several elements. Okay, the elements are connected to each other by node. The elements connect by each other by node. Okay, and then each node is capable for moving in 6 independent direction. The 6 independent direction is mean the degree of freedom for one node have 6. The degree of freedom have 6 in one node, include 3 translation and 3 rotation. 3 translation mean we have 3 displacement component. For example, ux, uy, and uz, and 3 rotation. For example, rotate theta x, theta y, and theta z. So we have totally 6 degree of freedom for one node. Okay, but this condition is 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 okay for the 3D structure. When we consider the 2D problem, one node only have 3 degree of freedom. That is, we have 2 translation and 1 rotation, right? USUY and theta d, for example, like this way. So these are called the degree of freedom at a node. Okay? And the relation between an element and its surrounding node can be described by the following equation. K matrix times U vector is equal to force vector. The elemental stiffness matrix K matrix elemental stiff matrix is derived from the geometry, material property, and the element property. Okay, later I will show you how to get the element stiffness matrix. The elemental loading vector here describe the force actives on the element. Okay, the unknown value of displacement. The displacement vector is the unknown in this equation. It describes how the node are moving as a result of the applied force. Okay, so one element product one elemental equation. For example, if we have 10 elements in this structure, we can get 10 elemental equation. Totally 10 equation. 同学，基本上我们在前面步骤的时候，可以把这个结构做离散化。那基本上离散化以后呢，每个 element 呢都会得到一个所谓的 element 的一个进度矩阵方程式进度矩阵的一个方程式，也就是 k 矩阵乘上我的未知的一个位移的向量以后呢，会等于我的力量向量。那其实每一个 element 都可以得到这样的一个 equation， 这样的 equation。那如果我今天的 model 呢，总共有10个 element， 那你就会得到10个这样的 equation。每个 element 都有它的 elemental stiffness matrix。那每个 element 都有它的一个 element 的进度矩阵。这个进度矩阵呢，不外乎会由它的这个结构的一个尺寸 geometry 和材料性质，还有它的就是杨氏系数啊等等这些组成。那等一下后面我们会说明这个 K 矩阵到底是怎么样得到的那一般来说，我们在现今的那个有限单元法里面呢，我们通常的节点位移是一个未知数。那节点位移把它全部排列起来的话，它就是所谓的位移的一个 vector 位移的一个向量。这些位移的向量每个位的里面的每个位置的一个位移呢，就是我们要带球的一个地方。The next, the element stiffness matrix are assembled into a global stiffness matrix. The rods are also assembled into a global rod vector. The result in the following matrix equation for the overall structure. So you can get the overall global stiffness matrix and the global displacement vector and the global force vector. Okay, after assembly. So it means how to get this equation? We need to assembly, right? We have a assembly procedure. It means, for example, if we totally we have the 10 equation elementary equation. After assembly procedure, we can get a global equation. How to finish the assembly procedure? We will expand the detail later. OK， 同学，基本上下一步呢，就是把每一个 element 的一个进度矩阵呢，进度方程式呢，进度矩阵方程式呢，把它组装成一个 global 的一个进度矩阵方程式。如果我们今天有10个element 的一个进度矩阵方程式的话，那组装完以后呢，我会形成一个更大的一个的进度矩阵方程式，我们就称为 global。这个就是整个结构的一个进度矩阵的一个矩阵和这个进度矩阵方程式了。好，那怎么做完这个组装的动作？那我们等一下会有一个 example， 还有 detail 的一个说明。OK， next slide just show you how to apply the boundary condition. Okay, the next step is just apply the boundary condition to the model. Okay, so to avoid the rigid body motion, so it's in other words just constrain the model. Mathematically, this can be achieved by removing load and current corresponding to the constraint degree of freedom from the global matrix equation. Okay, as reference this figure, we apply the boundary condition to this edge. It means, for example, these 3 nodes are constrained, right? So the degree of freedom, for example, displacement or rotation are 0. It means the matrix for certain row and the color will be removed, and the degree the matrix. Okay. 同学，下一步呢，基本上就是施加所谓的边界条件哈。那边界条件一施加的话，基本上你的进度矩阵或是你的进度矩阵某些的列跟行就会被消去掉。那基本上也就是说，防止它所谓的rigid body。那基本上这样的话，我的 geometry 就不是情意的一个情意点情意点。Okay, and finally, you can get the global matrix result by solving the periods the global matrix equation to determine the unknown, the nodal displacement. So this is why I talk about that the displacement is the raw data of the finite element analysis. So once you get the displacement, you can get the strain, and then by the Hooke's law equation, you can get the stress at each location of the structure. So this is the while the element strain and the stress are then computed by the nodal displacement, and by this after that you can plot the stress frigid plot. Okay. So next slide just summary the finite element method. The first step is to represent the continuous the structure R as a collection of the discrete the element connected by the node. and then derive the element stiffness matrix from the material properties, element property, and the geometry. Next, assembly all element stiffness matrix into a global stiffness matrix, K matrix here. Okay. Then assembly load into a global load vector, F vector here, and apply the boundary condition to constrain the modeling, and solve the matrix equation K matrix times U vector equal to F vector for the nodal displacement, and compute the strain and the stress from the displacement result. So the previous slide just summary the procedure of the finite element methods, and this slide just show you the type of the finite element method. There are two different types of the finite element method. The first is the displacement method that we have used now, and another kind is the force method. In both methods, equivalent equation, compatibility equation, and the stress-strain relation are used to generate a system of equations that represent the behavior of the structure. So it means we can use the three equations: equivalent, compatibility, and the stress-strain relation to get the element matrix, element stiffness matrix, and the element stiffness matrix. Okay. In the displacement method, the green point is mesh point. Displacement are the basic unknown in the system of the equation. This is the unknown. The nodal displacement is an unknown item that we need to solve, not the force. But in another method, the force item is the unknown. Okay. So in force method, the members force are the best unknown in the system equation. Both methods can be used to solve structural problems, but the displacement method is used by most modern finite element code. Okay. So in our case, we also use the displacement method, not the force method。同学基本上有两种那个有限单元法的一个表现方法哈。那我们在前面的讲到的那个未知数啊，就是节点的未知数呢，都是节点的未知数呢，都是 displacement 位移。那有些表现方法呢，所以这时候得到的矩阵呢，叫做进度矩阵，对不对？就是 element 的一个进度矩阵。那如果今天的未知数呢是换成所谓的 force 的话，force 的话，那前面的那个进度呢，它对应的进度矩阵呢，就不是对应的矩阵就不叫做进度矩阵了，而称之为柔度矩阵那这两个方法都有人使用，但是以现在目前的主流的有限单元法的coding 呢，或是解法呢，基本上都是以位移为主位移当做节点的主要的一个未知量。Okay. Okay. Next slide we will show you the key concept of infinite element method. Okay. Include the displacement method, how to formulate the element stiffness matrix, and then the matrix assembly and the decomposition. Okay. So first, we will introduce the displacement method. All the structural engineering analysis must satisfy the following three general conditions. The first, the equivalent of the force and the member. It means summation F equal to 0, summation momentum equal to A0。基本上呢，所有的结构分析呢，必须满足以下三个情况哈。第一个就是所谓的静力平衡，静力平衡基本上就是合力为零，合力矩为零。And the second is the strength and the displacement relation, also called the capability of deformation. Ensure the displacement field in a deformed continuous structure is free of walls or discontinuous. What is the strength and the displacement relation? Everybody know? The relation is the definition of the strength. It means the strength equal to displacement over original length. The strength is equal to displacement over original length. So the definition is just the relation of the strength and the displacement. OK， 同学，应力跟应变的关系式就是应变的定义哈。应变的定义意为来看的话，就是我的伸长量除以原长，伸长量除以原长是不是代表我的应变？那伸长量就是位移量啊，位移量跟我应变关系式就是透过除以一个原长一个比例关系哈。And the third is we need to know the stress and the strain relation, also called constitutive the equation. Just the Hooke's law. For a linear material, the generalized Hooke's law says like this way. Sigma stress vector is equal to Young's modulus, elastic modulus matrix times strain vector. Okay, where stress vector include 3 stress component. 6 stress component. 3 is normal stress. Another 3 are the shear stress component. The epsilon vector is equal R has 3. It also has 3. The strain component also has 6 strain component. 3 is the strain, normal strain. Another 3 is shear strain. And the matrix E is 6 by 6 matrix of the elastic constant. Okay. For the displacement method, these 3 conditions can be used to generate a system of equations in which the displacement are unknown. The stiff matrix K is used to relate the force active on the structure and the displacement resulting from this force in the following manner. Okay, by this equation, where vector F and the K matrix and the U vector are defined like this way. Okay, you can understand by the following the deformation, and then boundary condition are applied to prevent rigid body motion, and the system of linear equation is solved by the unknown U vector. Okay. Next, we will expand the detail how to formulate the element stiffness matrix. A key step in the displacement method is the formulation of the element stiffness matrix. So this step is very important. Okay, about how to get the element stiffness matrix. Each element in a finite element model is presented by an element stiffness matrix Ke. Okay, sorry, this is smaller k, not large k, right? And then I will give you an example for a single law case study to demonstrate the element stiffness matrix formulation for a law element. OK， 同学基本上在位移法这个部分呢，我们最重要的步骤是如何得到这个element 的 stiffness matrix 哈。那基本上每一个 stiffness， 刚才我讲过的，就是说每一个 element 里面呢，它自己都有一个 k 矩阵。不好意思，这边打错了哈，这边应该是小写的 k。那外标有一个小一的话，代表是这个矩阵呢是属于这个 element 的哈，是属于这个 element 的。那以下呢，我们会有一个例子呢，来说明如何得到这个 element 的 stiffness matrix 哈。OK， this slide will show you a example for the case study load element stiffness matrix. Please consider an elastic load of a uniform cross section A and length L under axial load. Reference this the figure. Okay, this figure just have one element. The one element we have two nodes, node 1 and node 2. Node 1 have one displacement U1. Node 2 and node 2 have another displacement U2. We assume we have a force F1 applied on the node 1, and the node 2 have a applied force F2. Okay, and the law have one geometry, but have the original length L and the cross section A. We can simplify this kind of the structure just one element, load element. Okay. So this problem is belong to one-dimensional problem. So we can use the beam or spring element to do this. But in this case, we select beam element. Okay, just also call the load element. Okay, load element. 所以在基本上呢，这个问题呢是说有一个柱体哈，有一个两杆件，这个两杆件呢，它有一个长度叫 L， 那 cross section 是 A。那基本上呢，这个问题呢，如果只把它当做把它简化成只有一个有限单元法的模型的话，哈，它只有一个 element。那一个 element 的话，并 element 的话，假设它每个并上面只有一个自由度，因为它是一维的问题，所以它自由度只有displacement 的一个自由度。所以节点一这个 element 上面只有两个节点，节点一跟节点二。节点一上面的自由度就是 U1， 节点的位移量是 U1， 节点二呢，它上面的位移量是 U2。那假设在节点一跟节点二分别受到外界的力量就节点 force 是 F1 跟 F2。那这个 element 它本身因为是 load 嘛，对不对？有一个杆件，有一个并，它的原长是 L， 它的 cross section A。那在这个假设状况下面呢，去推导我们后续 所要推导的所谓的 element 的 stiffness matrix。Okay, so the how to get the element stiffness matrix. The step 1, satisfy the static equivalent. So summation fs equal to 0, right? It means f1 plus f2 equal to 0. So we can get the equation 1. Step 2, relative the strain and to strain. Step 2, relate the strain to the displacement. We assume that the load change less by and among delta L due to the age of load. Okay, so we can get the epsilon s equal to delta L over L. The strain in the load is like this way. Delta L equal to U2 minus U1, right? Because U2 is the displacement at the node 2, U1 is the displacement at node 1. So the U2 minus U1 is the total deformation of the load, okay? Over L equal to the strain along the x direction. The step 3, we can get the relation between the stress and the from the strain. So based on the Hooke's law, we can get this equation, right? Sigma x equal to Young's modulus times epsilon x. The next step is to relate the force to stress. From the deformation of the stress, sigma equal to axial force over A. Okay, so for the node 1 and the node 2, we can get the stress applied at this location, at this node. Sigma x1 equal to F1 over A. We have a minus sign here. Sigma x2 equal to F2 minus F2 over A. So next step is relate the force to the displacement. Okay, combine the equation 2 and the equation 3 into the equation 4. We can get this equation. And the rearrange, we can get the equation 5 and the equation 6. Okay? These two equations is the final result. And these two equations we can combine together by the matrix form. So the equation 5 and the equation 6 represent two linear equations, and with the two unknown values, right, U2 and U1, rewrite them in a matrix form. We can get this one. Okay. So from the matrix form, we can easy to understand in which item is the element stiffness matrix. This one, EA over L. Matrix 1 minus 1 minus 1 1. Okay, this item is the element stiffness matrix. Or you can rewrite like this way. 同学这边就是说我们最后可以得到第5式跟第6式哈。那第5式跟第6式呢，能够把它进一步的改写成矩阵的形式。矩阵的形式你就可以写成这样子哈，这个样子。那这个样子的一个表达方式呢，你对照前面 f 的 vector 等于 k 矩阵，再乘上 u vector， 对不对 ？f 我再讲一次 ，f vector 等于 k 矩阵 乘上我的 u vector。那这个 k 矩阵呢，就是刚才前面有讲的，就是所谓的 element 的进度矩阵。element 的进度矩阵如果对照起来的话，是不是这个 item 这个 item 就是所谓的 element 的进度矩阵？那注意一下哦，我们刚才前面有讲说 element 的进度矩阵是由什么来组成的？是不是这个结构的几何关系，还有它的材料性质？材料性质一样是 modules， 那几何关系就是 cross section， 还有它的长度。所以基本上这个 item 呢，现在标示出来这个 item 呢，就是所谓的 element 的进度矩阵。这边有写错哈，这边不应该大写，而是小写的 k 哈，小写的 k， 好，小写的 k。好，不过为什么这边用大写呢？是因为这整个结构只有一个 element， 所以它就直接用大写来写了哈，用大写来写了。好，we just consider again the element stiffness matrix is have the several geometry characteristic curve. Sorry, have geometry had a geometry item of the item and the material property here. Okay, if no problem, we will move to the next slide. The next slide just summary the approach we have introduced. The method used in the previous case study to derive the raw element stiffening matrix is called the direct method or the stiffness method. This method works well for simple elements such as rod and beam. 同学，前面的推导方法就是所谓的直接方法，直接法或是所谓的进度法，或是进度法。那基本上这种方式呢，只适用于比较简单的结构，譬如说就是一维的 rod 或是 beam 的这结构。For more complicated structure for 2D or 3D problem, we need to use the 2D or 3D element, right? So at this time, the direct method or stiffness method are not enough, so the variational method is used. The variational method is also known as the realized risk method. Assume the element shape function and the energy principle are used to derive the element stiffness matrix, and the variation method 变分法 is covered in detail in the textbook on the final element method. A list of the reference books on the final element method is included at the end of the handout. OK， 同学，这个变分法呢，这个 variational method 就是变分法，变分法。那基本上它是站在所谓的能量的观点来推导这个所谓的element 的进度矩阵。那基本上在我们这个课堂里面呢的稍后呢，后面呢会有一些部分呢会介绍所谓的变分法。OK, additional example for element stiffness matrix. The element matrix for a raw element under torsion is shown below. Okay, as reference this figure. Now we do not apply the axial force. Change as torsion here, right? Torsion apply at node 1 is T1. Torsion is applied at node 2, T2. Okay, so we can get by the fundamental principle from the mechanics of the material, we can for the node 1 and the node 2, we can get the final result by the matrix form. Okay. If we consider another case for bin element, one bin element, we apply the bending. We apply implant shell and the bending at the node 1 and 2. The final result are shown here. It should be noted that at this moment we have 4 unknown parameter. One is the 2 is the y directional displacement, right? Another 2 is rotation theta z1 and theta z2. So totally we have 4 unknown value here. 同学，这是另外一个 case 哈，这个 case 是说我这个病呢受到剪力跟弯矩的作用，哈，在平面上的剪力跟弯矩的作用。那如果是这样的话，代表说我节点1跟节点2，它的剪力、它 y 方向的位移跟它的 rotation 你都必须要求出来。所以基本上呢，总共会有4个未知数。那这时候你的 matrix 呢是4乘4哈，就是16个4乘4的一个那个的 element 的一个进度矩阵。So we have another case study. We consider the 2-lot assembly. So from this example, we will learn how to finish assembly, the procedure. The following case the study demonstrates the assembly of the individual element stiffness matrix and the solution to the entire problem. Okay, so from this figure we can see that we have 2 bin, right? We have 1 bin, but L1 have 1 cross section, L2 and L1 have 1 cross section, L2 have another cross section. So for this kind of problem, we will divide into 2 lot element. For element 1, we have node 1 and node 2. For element 2, we have node 2 and node 3. Again, node 1, we have a displacement U1 and F1 and the force F1. For the node 2, we have a displacement U2 and the force F2. For the node 3, we have the displacement. We have displacement U3 and the force 3. But at this moment, we do not consider the boundary condition here, because this bin is the cantilever bin, right? The boundary condition we will apply later. Okay. So write the following again. Sorry. Okay, this case just talk about the bin which have 2 elements. Yeah. So the 2 lot element we have 3 nodes. The element 1 is node 1 and node 2. Element 2 is node 2 and node 3. And each node has 1 degree of freedom. So along the x direction. So based on the previous the case, you can get the element matrix for the element 1 with the node 1 and the node 2, and get the element matrix for the element 2 with node 2 and node 3. So So next slide just show you the detail for the stiffness matrix for the element 1, K1, and the stiffness matrix K2. So write the following element stiffness equation based on the previous the revelation of the stiffness matrix for a load element. We can get this too. 同学，根据前面的那个说明呢，就是比较简单的说明，我们可以得到for element one 跟 element two 呢，我们可以得到两个element 的进度矩阵哈，进度矩阵分别写成 K1 跟 K2哈，注意一下这边的 K 是应该都要小写哈，并不是大写，代表只是元素的一个进度矩阵，并不是整个 global 的一个 stiffness matrix. So next we will explain how to assemble the element stiffness matrix become the global stiffness matrix. So then we will rewrite the stiffness matrix in a simple term. It means the K matrix 1 for element 1, the item within the matrix, for example K1, we use the simple K1 to represent the E1 A1 over L1. We use the simple K2 to present the items of E2 A2 over L2. So the K matrix for element 1 and the element 2 can be rewritten like this way. So this is easy to express the equation in the following equation. 同学，我们使用那个小写的 K1 跟 K2 呢，分别代表这个进度矩阵里面的一个项次哈。譬如说，我们使用 K1 呢等于 E1 A1 除以 L1，E2 呢等于 E2 A2 除以 L2，分别那个替换里面的原本的进度矩阵里面的一个项次，这样写起来会比较简洁一点哈，简洁一点，不会让我们在后面在表达 equation 的时候会觉得说好乱，所以基本上用这方式会比较简洁，而可以表现。但是要记得 K1 是什么 ，K2 代表意义是什么。Okay, let us move to the next slide. Next slide just talk about how to assemble of these two elements. Assemble these two stiffness matrices by superposition. It is noted that the superposition, the resulting matrix is called the global stiffness matrix. How to finish the superposition? For example, K1, this is K1 matrix. This is K2 matrix. So for the K1, so first we need to write the K1 matrix first, and the second row and the second color, the item at the second row and the second color, this one. It means the right down corner, the item at the right down corner of the matrix should be superposed with the up left corner of the matrix. For the item at the up and the left corner of the matrix within the K2. Okay? This one, K1 plus K2. Okay? This is for the element 1. This item, this matrix is for the element 2. So I repeat again. The item at the right down corner of the stiffness matrix for the element 1 should be superposition with the up right corner of the stiffness matrix for the element 2. So by this way, we can create the 3 by 3 matrix. The 3 by 3 matrix is the global stiffness matrix, and the following we can get the force vector and the displacement vector。同学怎么做这件事情呢？基本上你看哦，这边是第一个 element 的进度矩阵，这个呢是第二个 element 的进度矩阵。那我们会使用什么重叠原理去做这件事情？基本上呢，这个是你可以视为是第一项 第一列、第二列，第一列、第二列，这是第一行、第二行。那注意一下，对于这个 element 2而言，这个是第二列、第三列，这是第二行、第三行。注意一下，所以这个 K1 的位置呢是在第二列、第二行。那这个呢是在第二列、第二行 K2。所以第一个 element 进度矩阵的右下角的位置，跟第二个进度矩阵的左上角的这个位置呢，基本上是在矩阵里面的同一个位置，都是第二列、第二行、第二列、第二行。所以基本上在组装的时候呢，在同个位置的地方的 item 必须要把它加起来，加起来 superposition， OK， 所以就是会变成这个样子。其他没有加到的地方就是补零 ，OK， 那这样的话就会形成3×3的一个矩阵。那这个矩阵呢，就称为 global 的一个进度矩阵。好，那同样的，如果对于 force 或是那个 displacement 的话，也是这样做也是使用 superposition 把它加起来，主要是针对那个 force force 有时候这个会有两个譬如说 F1 加 F2 F1 F2 可能会加到某一个 term 变成最后是 F2 好，大概是这样子。好，it should be noticed that at this moment we do not apply any boundary condition here. So next we will consider the boundary condition. So apply the external loading and the boundary condition to the structure. For example, for this example, we can come back to this item. We can see that we apply the axial force at the node 1 along the negative direction P, and we fix displacement at the node 3. Okay, so based on the problem, we can get this F1 equal to minus P. Node 2, we do not apply any external force. F3 equal to 0. Okay, we can get this. F1, F2, F3. This is for the external loading. 同学从前面的知道就是说在节点1、节点2、节点3，只有在节点1的位置呢有施加 force 轴向负载，而且是在负 x 的方向所以我们加一个负的一个符号。那 F2 跟 F3 呢基本上是没有施加的外力，所以我们补零进去。OK, but at this moment we do not apply the constraint equation for this matrix. So next step, we need to impose
the boundary condition. The right end is fixed, so the U6 equal to 0. This is achieved by discarding row 3 and the color 3 from the global stiffness matrix. Okay, so discarding row 3 and the color 3, and we can get this item, this equation. So next step, we will resolve the U1 and the U2 because at this equation, these two items are unknown. So now we will solve the match equation for these two equation. 同学，下一步呢？当我的边界条件进去以后呢，刚才前面 case 就是说 U3 的这个位置呢等于 instant cantilever beam 嘛，所以 U3 的这个节点的位移是等于0。所以当我的施加的外溢跟边界条件进去以后呢，基本上我就要解这个两个方程式，对不对？两个方程式，两个未知数，所以我们就可以解这个矩阵哈，解这个未知数了。So now we how to solve the U1 and the U2. One way is to solve equation is to multiply both sides by the inverse of k. U vector is equal to inverse of k multiply f vector. But actually, the inverse of the stiffness matrix to solve the system of equation is highly inefficient. FEM use a more efficient matrix to the composition procedure rather than the matrix inverse method. Okay. This method is Gaussian elimination approach. 同学，基本上呢，有一种解法就是说你要解这个矩阵的话应该各位同学应该学过，两边可以等成它的一个反矩阵，对不对？K 的这个矩阵的反矩阵就可以到这个 U 这个未知项的这个 U 但是呢，实际上呢，这样的做法前提是有可能会 singular 主要是这个 k k， 等一下后面讲说这个 k 它本身不能为0，对不对？第二个它也要square matrix 就是要这叫什么 square matrix 是什么正方形的矩阵才能做这件事情，不然的话会有状况那所以基本上在解这个这个矩阵的一个未知数的里面的未知数的时候呢，通常我们会使用所谓的高斯消去法。好，那之后会有那个其他的那个详细的说明。The inverse of K matrix require the K be square and let the determine K unequal to 0. That is non-singular. If rigid body motion or mechanism are not prevented or constrained, the structure is unstable and the stiffness match will be singular. This is very, very important. So based on this reason, we do not use this approach, right? We need to find another approach, just the Gaussian elimination approach. Therefore, the set of the constraints you apply must be able to prevent any possible rigid body motion in 3D space. 同学，基本上呢，这个是说，如果 inverse 的话，其实我们要确认，第一个我们要确认我们的 rigid body， 我们那个 constraint 能够足够要能够足够去避免这个 rigid body motion。另外一个，如果使用在数学上来说，如果你使用这个 K 矩阵的反矩阵的话，很容易达成这个 singular。那刚才老师有讲的，就是有两个理由。你这个使用那个 因那个 k 的反矩阵，它必须要 square 的一个矩阵，而且它 determine k 要不等于0才能做这件事情，不然的话，这个会解不出来。好，这个方式是行不通的。好，OK, let us move to the next slide. Next slide 就是 example to expand the constraint. The please see please watch this figure. This figure. This is a bin and 2 roller here. The constraint is enough for this the problem. No, because because the structure still have the possibility to move along the horizontal direction. How about this figure? This point is constrained along the x and the y direction, right? So this point is fixed. How about this? We have a constraint. We do not have a constraint along the y direction. But this structure cannot have a rigid body motion. So this figure, the constraint is good enough. Okay. Let us move to this slide. This slide just expand the procedure of the general structure. The same procedure used for the 2-load model in the previous case can be extended to a general structure such as the aircraft structure shown below. So it means the aircraft, even we analyze such the complicated structure, we still can use similar approach to get to solve the finite element problem. The difference between the model we talk about and the aircraft is the number of the element in this case is more than these two, right? Because this one we just use the 2 element, but for this case maybe 100 element and so on. So it means the matrix may be 100 by 100 or 200 by 200. The matrix is larger. So if we want to solve the unknown displacement by our hand, this is very difficult, right? So we need to assessment. We need to the help from the computer. 同学，基本上呢，这个步骤呢，可以适用在譬如说在解那个航空器的这些结构的分析里面，结构体的分析里面，那基本上沿用前面的这个双杆就是并的一个分析同样的手法可以分析这个，那差别只是在于说我的解的 element 的数目较多，那这样的话，实际上你可以想象其实 element 数目一多的话，我的未知的那个位移量跟未知的位移量要求的未知位移量数目也变多，那换言之，也就是那个 global 的 k 矩阵就变得很大很大，对不对？那如果我这样要用手动方式，像考试方式用手动这样解的话大概有难度而且也容易写错，所以这时候借由这个电脑的求解就变得很重要，So these two highlights spherical elements are represented by these 2 element stiffness matrices developed in the previous case study. So the stiffness characteristic of the rest of the aircraft are obtained by assembly the individual element stiffness matrix to the global stiffness matrix using the same procedure as used in the two-law model. Show us the global matrix for the aircraft will be represented by this way. Okay. So from this case, you can understanding the critical procedure is how to assembly the element stiffness and form and generate the element stiffness matrix. Okay, let us move to this slide. This slide just talk about other application for the finite element methods. In general, the finite element method can be applied to any continuous described by partial differential equation. For example, steady state heat conduction. 同学基本上除了结构分析之外，也可以适用在其他的分析哈，比如说在这个静态的一个热传分析。For the steady state heat conduction case, we will replace the structural stiffness matrix with the matrix of thermal conductivities. And in this case, the just have single degree of freedom at each node. That is temperature, not the displacement. Okay. And for other field, for example, dynamic flow, fluid flow, and wet propagation, and so on. 所以还可以适用在除了热传分析的话，可以适用在比如说动态分析啊，或是电池啊，或是热传的，或是那个流体的一些分析啊，波传等等哦，都可以使用这个有限单元法。所以它的现在适用的范围就变得非常的广泛哈。Okay, let's move to the next slide. Next slide 就是provide you some reference for the finite element textbook and the reference book, and for example, Cook. Okay, so many university take it as a reference book, but this book have so many methods. You need to have a excellent mathematical ability to handle the equation shown in this test, and the other reference book are listed here. And then next topic, I will talk about the unit considered in the finite element software. Actually, when we talk about the units used in the finite element, we need to take about the following into account. The first, the finite element software do not know what unit you are using. It is up to you to use a system of consistent units in the finite element model. This is very important because the unit you use, you need to understand what units you use in the software, and then should be consistent. Okay. If you do not consider the unit, the result will totally wrong. This means that you must input all model quality such as grid point, location, elasticity modules, apply loading, and so on, using a consistent system of a unit. You must also explain the model output quality such as displacement and the stress in the same consistent system of units. Okay, so this point is very important. Is very important. 同学在有限单元法里面的软体，基本上这个软体里面都不知道你使用的单位是什么。好，它不会说知道你的单位是公尺啊、公分啊，或是微米啊这些。那所以这些单位在使用的时候呢，使用者自己要必须知道你输入的单位是到底是公尺吗，还是微米呢，还是什么都可以。但是重点是你的单位呢，必须的系统呢必须要一致，好，一致。你不能说我的 model 里面呢使用的长度单位是公尺，但是我的杨氏系数啊，或者 apply force 呢，譬如说杨氏系数，它的单位呢可能就是以微米啊，微米的尺度来做这个计算，那这样它可能会多好多零或少好多零，对不对？那这样的话，变成说你 output 的东西就 output result 呢，那个量级呢就不一致了。那这样会造成你出来的错误那个结果呢就会差，跟实际状况会差很多所以这是必须，这个是很重要的就是说你单位的一致性在有限单元法的使用，你必须要一致，而且只有user 自己要 check 这件事情因为这个软体呢不会告诉你这个单位是什么，它没有单位没有单位，必须你自己要定义清楚。那所以呢，基本上每个人做的那个，同一个题目呢，它使用单位不一样它基本上它的做法应该会不一样才对所以基本上来说别人会看不懂你做的模型和分析的结果，你必须要自己去说明说这个你怎么去施加这些的，譬如说你的做 mesh 啊、边界条件的设定啊，还有你输入的材料系数是怎么样子，你必须要揭露这些资讯。那当然出来的结果的话，也只有你自己知道说它的量级是怎么样子，到底是 MPa 呢、GPa 呢，还是怎么样的量级，或者它长度是变形多少等等，都必须要你自己来去user 使用者自己说明这件事情。Let us move to the this slide. This slide just give you as an example. We consider the Newton's second law. A consistent set of units must satisfy the Newton's second law of motion. F equal to ma. 同学，基本上你确认你的单位是不是一致性，可以使用那个牛顿第二定律In other words, one unit of force applied to one unit of mass must result in one unit of acceleration. 就是基本上你使用一单位的力量，就要等于一单位的质量乘以一单位的什么加速度。那 force 质量加速度基本上大家都有那个对应的那个单位，对不对？你可以用这边来做 check However, you are in about a system of the modeling unit using this equation about to check length. So, Newton's second law of motion contains the units of the force, mass, length, and time. 在这个牛顿第二定律里面有力量单位、质量单位，还有长度单位，还有时间单位，对不对？ We can choose any three of the force units as our base unit. The force unit is then derived from these three base units. 那这边有4个单位，对不对？4个单位，你可以先确认其中3个，固定其中3个当做基本的我们已知的，那你可以去推导第4个对不对对，第4个就对，可以推导出来是对不对的，去 check 这件事情。利用这方法，后面会有个 example And commonly used system of unit. The two major systems of units used by engineering and statistics are the International System of Unit (SI) 就是公制 and US customary assistant， 也就是英字号，或美字号。The SI system is the modern version of the metric system. The base units include the meter and the kilogram or gram mass and the second. 基本上公制就是 m、kg、second 的这个基本单位。那英制的话，就是各位同学参考一下Okay. For the SI unit, in the SI system of units, the base units are the meter and the kilogram meter and the second. The fourth unit of the unit or the force is derived from the Newton second law and is called the Newton N. So the N is equal to a kilogram times meter per second square. Let's check the system of units using Newton's second law. 1 unit force is equal to 1 unit mass multiplied 1 unit acceleration. Check. E kilogram multiplied 1 meter per second square is equal to 1 Newton? Yes, right. So this equation, the unit for this equation is consistent, right? 同学，基本上呢，你从这边可以知道说牛顿我们定一个那个力量单位叫牛顿。这个牛顿的基本上的定义就是 kg 乘上公尺除以秒的平方，对不对？那你看从这个力量的单位是什么呢？是根据定义 F 等于 ma，n 的单位是不是 kg？ 那加速度单位是 n 除以什么秒平方second 的平方，那乘上去是不是就刚好是牛顿的单位呢？答案是所以这个是 consistent 的。So when we change the unit from the matrix matrix to millimeter, from meter to millimeter as the unit of length. The unit of force is the Newton and the unit of time is the second. In order to satisfy the Newton's second law, the Newton of the mass must be the megagram, and the matrix tone T or the tony TA. Okay. The megagram equal to 1,000 kilogram, right? Let us check the system of unit using Newton's second law. Is correct? Yes, correct. Again, using the similar approach to check this point. 那基本上呢，我们在 SI 制SI 值常用的那个单位是 millimeter 当做长度单位。那这时候你要确认你的使用的那个质量单位要变成什么呢？要变成 megagram megagram 就是10的6次方克10的6次方克不是 kg 咯，是10的6次方克咯。好，那10的6次方克就等于1000 kg 1000 kg 呢，再乘上我的加速度，加速度刚才不是说已经变成 millimeter 吗 ？millimeter 除以什么？长度变成 millimeter 除以秒平方，你这样乘下来的话，是不是也是牛顿？那这样也是对也就是说你在 ANSYS 里面如果考虑到质量的话， 以这个 case 来说的话，假设你长度是millimeter，你的重量就要写成10的60方克，那你的加速度就要改成这个样子，你才会得到单位还是牛顿哈，牛顿。We will skip this slide because the similars the approach we have explained in the previous slide。同学，这个音质的说明哈，或者音质或美字的说明呢，就请大家自己去 check 哈。那 detail 的部分我们在前面已经讲过了哈。We will still skip this slide. We just expand the detail by the SI system because SI system is the popular system we have used in the engineering. Okay. If no problem, we will we have finished the chapter. This is the chapter of the lecture. Okay, thank you.